Hello, here we're going to go through VISI strip to unfold this metal part and then go through how some of the unfolding calculations work through VISI. We'll start by selecting part study here, and then selecting the part. When you get to this part properties window, you can select different properties about the part itself. You can select a family of materials, and then within those families you can select a specific material. And if you have one that's not already installed with VISI, you can install it yourself as long as you have the material properties. And then under this unfolding data, we've got two separate options, the neutral fiber methods and the unfolding type. For the neutral fiber methods, basically when you bend the sheet metal part, it produces stretches and compressions on the part. If the tension stress is on the external side of the fold, then the compression of the material is on the internal side. The stretching increases the original dimension of the part, and the compression reduces that dimension. Now the boundary between the stretching and compression is the neutral fiber, where the original dimension of the part remains unchanged. And VISI offers these two methods for finding this value. You can either select manual, where you get a choice of 1/3, half, 2/5, or 5/12. And that's just how far through the thickness of the metal you'd like the neutral fiber to be. Or if you select automatic, you have the Romanowski, the Oberkaiser, or the sharp corner methods where an algorithm will automatically go through and calculate where the neutral fiber should ideally be to maintain the integrity of the part. Under unfolding type, you have constant length unfolding, and you have linear extension both before and after the bend. For constant length unfolding, it uses an algorithm and it forces the arc length of the bend on the neutral fiber to remain constant. When the bend's unfolded, the radius and center point of the selected bend have to change to maintain that constant arc length. And then for constant radius, that uses a separate algorithm that forces the radius of the bend on that neutral fiber to remain constant. And the linear extension after the bend unfolds the surface with the same radius and adds a plane surface after the bend. And before the bend works in the same way, except it adds that plane surface before the bend. Okay, so we'll select this here. We'll select the face and a point. And we're going to start by grouping this down here as a bead because we won't unfold this linearly. We'll just put that in later as part of our die construction. And then we've moved to the unfolding tab. If we hit the automatic unfolding, you'll see it'll create a unfolded part right here. And then in the next step, we can go through step by step and unfold it, working our way back to that unfolded part. So when you click on the bend, you can change the angle value, so we'll change that to 45 and bring this up to 45, and you can keep working your way back step by step to get to the flap length that was created. We'll add one more step and take out this little bend. And there we have each step we're going to need whenever we move on to the next step for the strip construction. Last thing we can do is just rebuild the solids, and we've got solid parts for each step of the unfolding process. And that's how pretty straightforward it is, and how VISI works behind the scenes to take your original part and unfold it step by step to help you get ready to create your strip. Thank you.